All right, welcome. This is CSS as Bytecode. I'm Richard Feldman. So first of all, hello, Bratislava. Good to be back. Good to see everybody. So I want to start off with a quick question. So let's imagine that a designer comes to you with this glorious mock-up, this extremely complicated web page, and just imagine that you're sitting in front of your laptop with your fingers above your keys, and you're thinking, okay, I'm going to start implementing this. How many people, quick show of hands, could start implementing this horizontally and vertically centered box without looking anything up? Just immediately start typing. Okay, that's like a single-digit percentage maybe. And like, keep in mind, this is a room full of experts, right? I mean, we are front-end developers. This is what we do. And when I'm using like Google Slides, which is what I use to make this talk, like this is the UI for horizontally and vertically centering things. I'm like, if I want it horizontally centered, there aren't even any text in these UI. I just click this icon. If I want it vertically centered, I click this icon. So why is this different? I mean, and what are the consequences of this? There's sort of like a lot of things like this in CSS, where these things that feel like they ought to be straightforward turn out not to be, and they sort of accumulate, and they end up with a lot of frustration. This is a sentiment that quite a lot of people seem to resonate with, at least based on the number of retweets and likes and number of people laughing in the audience right now. And so I think it's a reasonable question to ask, like, why? Why is there so much frustration out there? Why are so many people frustrated by using CSS to lay out their websites? And I learned something about this, and I think I have a plausible answer to this question, which is just that CSS was never intended to create user interfaces. That's not what it was designed for. And I kind of found this out when I was reading about the history of CSS in this extremely entertaining article, The Languages That Almost Became CSS by Zach Bloom. If you've never read this article, I highly recommend checking it out, because it kind of talks about, it just goes through the history of like, how did we end up with the layout and styling system that we did. And he starts with talking about back in 1991, Sir Tim Berners-Lee introduces the hypertext markup language, which had an extremely fancy logo. And this was just for content. Like, it was for writing semantic content that you would send out to people over the web, and that was all. There was no styling whatsoever in the initial draft of HTML. It's just a way to structure content. And then at some point, people got this idea, hey, maybe this content might like to be styled, which you think, yeah, that's a pretty reasonable idea, right? You see this big wall of text, it'd be nicer if it were styled. Said, yeah, but let's take it a step further. We got this good idea. We're going to separate the content from the presentation. We're going to decouple these. It's going to be a separation of concerns. And here's why we're going to do that. The idea is the authors are going to create the content and describe it using HTML. And then when it arrives at my browser, I'm going to style it. Like, the end users are going to write style sheets to style the content. Because, hey, what if I like a different font than somebody else likes? I want to see my articles in that font. Or I like different colors. Like, maybe I want to use different colors for some articles and different, like this was the idea. This was the design goal. So we've sort of like retconned this thing that like the separation of concerns was for programmers, but it wasn't. Like if you look back, like the whole idea was that the separation of concerns was because there were going to be different people doing the content authoring from the people doing the styling. So this was the idea, and there were these proposals for how to describe these user-defined style sheets. This was one, PWP. That's not what we ended up with. There was another one called Fossy, which is like very XML flavored, like a little bit later. There was DSSSSSL. There's like 1,000 S's in there. This was kind of Lisp looking. And there were also some people who thought this was a bad idea. So here's somebody, quote, "Style sheets are an artificial construct inflicted on us because of the whole non-presentation philosophy we've been using. I find it somewhat reassuring to know that people still argued angrily on the internet before like Twitter and Reddit. This is cool, it's 1994. I mean, we've been doing this stuff for longer than I realize. And so this was like a controversial thing. This was not like, oh, CSS, obviously. I mean, like for us, it's easy to have become accustomed to this being the way that it always was, but this wasn't the way that it always was. This is just where we ended up after, in 1996, browsers sort of ended up standardizing on CSS. That's what they decided to go with as the way for these user-defined style sheets. So hey, success, great. Now end users can finally style content. Mission accomplished. Okay. Fast forward 20 years to the present. CSS being, I guess it's 21 years now, CSS being 1996. And now the web has become the biggest user interface delivery platform in history. So this is what the web is sort of like best at. I mean, yes, there's definitely still plenty of content. Granted, it's being styled by professionals, not by end users. But really, the thing that's sort of like made the web take off is the fact that it turns out to be a fantastic application delivery platform, the most successful one in history. So what CSS was originally designed for was end users styling the content that they read. And if you think about it, like in that system, like why would you bother making it easy to horizontally and vertically center content? Like imagine the last time you were reading an article and like right in the middle of the article, it was like boom, on your screen there's something that's like vertically and horizontally centered. That'd be weird. Like when you're reading a block of text, you just care about the flow from left to right and top to bottom, or right to left as the case may be, depending on your language. But this is not really something that comes up in that use case. And there's a lot of things like this, where there's some set of things that you really want if you're building user interfaces, and there's a completely different set of things that you want if you're trying to design for these design goals of separating the people who are writing the content from the people who are styling it. So, as we now know, 20 years later, this is not actually something that a lot of people want. So much that, in fact, like some browsers have been taking this out. Like they've removed the ability to have end-user customized style sheets in the browser at all, and you actually have to install an extension if you want to be able to do that. So that was what it was designed for, and then what it actually ended up being used for is creators styling content, and of course, building user interfaces. So we have somewhat of a similar situation when you think about like where all this frustration is coming from with JavaScript from 1995. So 1995, JavaScript was created. Famously, the story goes that Brendan Eich designed it in 10 days, and what he was doing in those 10 days is he was designing it to build gigantic multi-billion-dollar web apps. That was what he knew that JavaScript would be used for. No, that was that was not the plan. But that was what ended up happening, again, because the web turned out to be such a great delivery platform for this. But that was not what it was designed for. It was just designed to make like basic real-time interactivity. The alternative was like plugins like Java applets, these really heavyweight things. It was designed to be something lightweight and kind of easy. It was not intended for these enormous code bases that we now have. But we've actually ended up figuring out some ways that we can solve these problems for ourselves, this sort of like design goal mismatch with things like compile to JS. So we now have many tools which compile to JS while keeping familiar JS semantics. So we have things like CoffeeScript. So CoffeeScript was really popular for a long time. Write CoffeeScript code, run it through a compiler, end up with JavaScript that you hand off to the browser. That kind of got replaced by a different compile to JS solution, Babel, which is compiling a future spec of JS or the current spec of JS into legacy JavaScript that older browsers can support. Same idea, just compile to JS. And of course, we have things like TypeScript that are getting more popular, which are compiled to JS, still same JS semantics. Like all of your JavaScript knowledge very much directly translates to using any of these three, but TypeScript adds things like a type checker and some other niceties. We've also seen more ambitious compile-to-JS projects. So these are compile-to-JS projects that have no semantic relation to JavaScript. So we've seen a couple of these at the conference. First, ClojureScript. David Nolan talked about that yesterday. We're going to see a little bit of Reason ML later today, Jared Forsyth, and me talking about Elm. So these are languages where they're saying, you know what? We don't actually have a semantic relationship to JavaScript. To us, JavaScript is bytecode. It's something that we use purely as a compilation target because we want to get stuff done, not because we actually want to embrace the original design of JavaScript itself. So this idea of JavaScript as bytecode is what these languages are doing. Similarly, we also have compiled CSS solutions that make CSS a little bit nicer. So we have, again, many of these things that sort of keep CSS semantics intact. So like Sass, for example. If you know CSS, a lot of that knowledge is going to translate to Sass, but pretty much all of it. Same thing with JSS, which is also at the conference. They're adding additional capabilities, different APIs, different ways of presenting CSS, but at the end of the day, ultimately, it's incumbent on you to have that CSS knowledge to be able to use these tools. Okay, what about something that has no relation to CSS? What about something that says CSS is just a compilation target? It's just bytecode. Like these languages that are doing the same thing for JavaScript. What goes in that box? Well, let me introduce you to Style Elements. So Style Elements is a library created by Matt Griffith. He introduced it at Elm Europe last year in Paris. And this is a library that is written in Elm. Didn't have to be, but it was. and it is. It compiles to JavaScript via Elm and to CSS and DOM. So it is a complete user interface abstraction. Like literally, it is conceivably possible that someone could use this library without knowing JavaScript, without knowing CSS, without even knowing how the DOM works, and still make a completely functional user interface that works and can be deployed on the web. That's the dream, and it's reality. And this is done using clean slate semantics, like really going back to the drawing board and saying, not how can I translate this concept from CSS and make it nicer, but rather forget CSS, forget JavaScript, forget all of that, and just say, I want to build user interfaces and I want to deploy them on the web. What's a nice system for doing that? This is a totally different design goal than what we had back in the 90s when this stuff was still early days and we were still figuring it all out. So some of the design goals in a more concrete sense, one is to say we want to create maintainable user interfaces. So this is where a lot of this frustration comes from, is that CSS, and not only was it not designed for user interfaces, but it certainly wasn't designed for large scaling user interfaces. Like we've heard from a number of people over the course of the conference about scaling challenges that people have run into. This is just as much a challenge in CSS as it is in JavaScript, if not more. Another design goal, long-term cross-platform support. If you're building a system for describing user interfaces, there's lots of different platforms. React Native has shown that there's a lot of value in being able to have one code base that is shared across multiple different platforms. iOS, Android, macOS, things like that. If you're designing this for this use case up front, you can do a lot of work towards making that a better experience. And finally, have one compatibility table. I love caniuse.com. I would love even more if I didn't have to use it. Just being able to say, if you use this library, you can depend on being able to support these browsers. Any layout primitives you want to use in this library, they will all work as far back as these browsers. You don't have to go look them up on a case-by-case basis. Okay, so these are the design goals. With that in mind, I'm going to introduce you to this new set of layout primitives. We're going to look at a user interface that I built using style elements, and we're going to walk through the concepts of working it out. I realize most people in here are probably not Elm programmers, so I'm going to speak in pretty general terms, but we are going to see a little bit of code later. But what I ask you is that when we're going through this, just try to clear your mind. Don't be thinking like, hey, how would I do this in CSS, or what is that compiling to under the hood? Just put yourself in the mindset of someone who's learning this stuff for the first time and saying, I'm going to learn this new set of primitives for how to do layout in the browser. All right, let's do this. So here's the very simple application that I put together. It's got a little bit of layout stuff going on. We got a little logo type thing over here. In the upper left, CSS is bytecode. It says built with Elm in the middle. It's a little tagline. We've got a drop-down menu over here with a little bit of hovering for stuff like that. So this is sort of the typical type of thing that you might imagine seeing in a web app. I've also made it so that we've got a little vertical and horizontal centering in the middle there so we can see what that looks like. And as I scale, it sort of stretches the image of beautiful Bratislava castle with the reactive logo staying centered no matter how far I do it. You might also notice that if you look at that tagline in the middle that says built with Elm, this is a bit responsive. So as I shrink it, that tagline goes away beyond a certain point. And also you might notice that CSS as bytecode is in the upper left, the menu's in the upper right. As I shrink it down further and further, those go away and we end up with just the menu that's just centered. So this sort of shrinks all the way down and is responsive. Okay, so let's walk through how that's built using style elements. So first thing to note is we're going to introduce you to a new layout primitive. This layout primitive is called a column. And the idea behind a column is that it flows from top to bottom. As you add elements to the column, like cells in a column, they just keep adding from top to bottom, stacked on top of each other. So there are two elements in this column. The top one is our header bar, and the second one is everything else, like the big image with the centered other image inside of it. So this is a column layout. This is our first layout primitive in style elements. Okay, so that's the conceptual idea. Now, if we zoom in a little bit on that first cell in the column, the first element there, that is a row. So this is a row as opposed to a column. Rows are laid out left to right. So as you add more elements to a row, they get added onto the end. So we have three elements in here. First one is the logo. Second one is the tagline. Third is the menu. So again, 1, 2, 3. As we add more things, they get added to the right. Okay, now let's zoom in on this one. This one we can lay out using the same primitives that we just talked about. This is another row laid out left to right. So again, 3 elements inside of it. There's also spacing in between these. So this is a new concept that style elements introduces for describing how to space things out within a row. So what this is saying is, let's say I give it a spacing of 5 pixels. What that's going to say is each element inside this row is going to have 5 pixels in between them. So we can increase that if we want to have more spacing, say like 10 pixels, or we can decrease that and have them more tightly packed. That's the idea, spacing. So this is another one of our layout primitives. Then we have the drop-down menu that appears below it. Again, internally, this is laid out as a column. Right, top to bottom. If we add another element in there, the fourth element would come below sign out. It would be at the very bottom of that column. Another layout primitive we have here is, these are not organized using spacing, which would put gaps between them, but we care about the hitbox here. Right? When we hover over these things and we want to click on them, we want to have a nice juicy hitbox, like anywhere in this area around a count, we want to be able to click and have it follow that link. So for this, we use padding. So padding is a way of expanding an element's size. Spacing does not expand the element size, but padding does. So if we want a bigger hitbox, padding is kind of the thing to go for. Okay, so we've got our column, we've got our padding going on, we've got our nice hitboxes, and we've got our row above that. A thing that you might wonder is, how do we get these to be organized this way? I mean, previously we saw how to nest things. You can put rows inside of columns, columns inside of rows, but this is sort of breaking out of that mold. This is something where we want to say, this dropdown, I want that to be below the menu. How do you say that? How do you describe the idea of one element being below another one, no matter where that other one is in the layout? Well, we have a function called below, and you give it 2 arguments. First, you say the thing that you want to put below the other thing, and then you give it the thing you want to put it below. And that's it. And now it just says this is just going to be positioned below the other one. That's the whole deal. Okay, so to sum up, just to recap what we talked about, we have this whole page as a column. It's got 2 elements inside of it. First, the nav bar, and then the second being the rest of the body. If we added a third one, it would go below because columns go from top to bottom. That first nav bar is a row. Within that row, we've got 3 elements, 1, 2, and 3. If we added a fourth one, it would go on the right because rows go from left to right. And within that row, we have another row, which is used to style the menu bar itself. Beneath that, we have a column, and it's got 3 elements inside of it. And the way that we positioned the one below the other is by using below, passing in the menu and then the thing that we want to go below the menu. Okay, using that knowledge, let's see if anyone can guess how we would go about laying out the logo in the upper left, which has 2 pieces to it. It has CSS, which is in white, and then it has as bytecode, which is in green. You may imagine to guess, let's just think about the 3 primitives that we've got. Row, column, below. Quick show of hands. Who thinks it's below? Who thinks it's column? Who thinks it's row? Yes, all right. So yeah, it's just another row. It's the same way as the menu in the upper right. So it's got 2 elements in it. The first one for the white portion, second portion for the green portion. Speaking of portions, you might also be wondering, okay, so if these things are stacked, why is it that this nav bar doesn't have these things stacked up all the way on the left? Why are they distributed this way? So you can give each element a width. And in this case, what we're giving it is a width that's not a hard-coded fixed value, but rather a portion. So in this case, I'm saying fill portion 1 for each of them. And that means you get to have 1 portion of the entire space. So each of these gets a fill portion 1. If I'd made the middle one have fill portion 2, then it would be twice as wide as the others. But still, all 3 of them put together would fill that entire space. So fill portion is just one of the other alternative ways to describe how wide you want something to be. Okay, you might also notice that these are aligned differently. So the logo in the upper left is left aligned. The built with Elm tagline in the middle is center aligned. And on the right, we have the menu being right aligned. How do we do that? Well, some new primitives: align left, center, and align right. That's it. We just describe them in terms of their alignments in the same terminology that you might use in like a word processing system. Okay, that brings us to the last bit, which is this logo, which is centered in the middle of this other image. So style elements has images that you can use to position however you want, and it also has a notion of within. So within basically says I want to use one of these elements as sort of a container for another element. So we talked about how this is a column with 2 elements in it. The bottom column, we're saying, okay, I want to put that logo within the other element. So now whenever I specify this thing's centering properties, it's going to be within the context of that containing element. So this brings us to the live coding portion of the demo. So here we have a version of this where I have not specified any centering information at all. So we have ReactiveConf logo and nothing at all going on over here. I'm going to add center and hit save, and it's going to reload. And this happened to me yesterday with the lightning talk. Eventually, the WebSocket gets disconnected. So now it's centered. Here, let's go back and do it with that. OK, so we start off with it in the upper left, and then we add center. And now it is horizontally centered. And if we want it to be vertically centered, we add vertical center. And now it's vertically centered. Ta-da! So a funny story about vertical centering is that this is actually how Elm was created, the programming language. Was Evan Szaplicki was working at Google, and he was helping out a friend. He worked on Gmail on the back end, and he was helping out a friend on the front end who was really wrestling with trying to vertically center something. And it ended up, they concluded that it was so difficult, they decided that they just didn't want to vertically center it after all, and we're just going to go do something else. Now, 5 years later, somebody has built his programming language, on top of his programming language, a way to make vertical centering much easier. And it's responsive. So speaking of responsiveness, let's talk about that. So responsiveness, how does that work in this system? So we saw that there are sort of 3 breakpoints here. So this is the main way that things look. When it gets a little bit smaller, the built with Elm tagline disappears. And when it gets even smaller, we're down to just the menu here. OK. So basically, Elm has conditionals, being a Turing-complete programming language, and you can know certain things, such as what's the viewport width. So if the viewport width is less than 640, then we're going to say render the menu centered. So menu here is a function, and it's just accepting how do you want it to be aligned. This is just a function that I wrote. I wrote a function called menu. I said I'm going to accept the alignment because I want the alignment to be different depending on how I'm doing this responsive layout. If viewport width is less than 1024, then I'm going to say list.append. So this is a way to combine 2 lists together. I'm going to say I want to have a list of these things. I want to have first the logo and then the menu, but I want the menu to be aligned right. So here's the logo, and then here's the right aligned menu. Finally, else we have take the logo and the tagline with the right aligned menu. So that's it. I didn't actually introduce any new layout primitives. All I did was just use the fact that I already have a Turing-complete language to just describe how I wanted my responsive layout to work. As simple as that. OK, that brings us to accessibility. So this is another thing that is sort of opt-in in CSS. And the idea here is to make accessibility more the default and less something that people throw on as an afterthought. So my coworker Tessa Kelly made this awesome package called Accessible HTML, which is a way to help you write accessible HTML in Elm. And one of the things that she did in that package is make it so that alt text for images becomes a required argument. You just can't forget to do it. If you don't put alt text, your code just doesn't compile. Now, of course, you can put empty string if you really genuinely think that there's nothing semantically there. But the idea here is to make it so that accessibility is no longer an afterthought. It's something that's just like front and center and not something you can forget about. And style elements does a lot of these same things, especially with form elements, not just with images. OK, so we've seen these set of primitives that we used to build this layout, right? Row, column, below and within, spacing, padding, alignment, and fill portion. And we've also seen how to make this thing responsive. So earlier I asked you to sort of like clear your mind and forget everything about CSS, but now I'm going to take that back and say, OK, let's actually think about this. Like, think about how you would build this same layout, this same responsive thing in CSS. What are the primitives you would use? How do they compare to these? This is a side-by-side comparison we can now do and say, like, what's the experience of building a user interface in this system versus in CSS? Like, what's that going to be like? What's it going to be like the first time I build it? What's it going to be like over time as I got to maintain it? So you can actually have a system that's designed for maintainability. We can have a system that's asking questions like, hey, how should deeply nested layouts interact? This is not something that was on anyone's radar when CSS was first being developed, because deeply nested layouts are a UI thing. Who's got deeply nested layouts inside an article? That just doesn't come up. Questions like, how can we make consistent APIs? It's really important that the web be backwards compatible, that websites from back in the day still work in modern browsers, which means you really can't delete things from the CSS API for HTML or from JavaScript. Now, if they're bytecode, that's OK. But if you're trying to work with them as first-class things, man, there's just inevitably going to be bloat. There can't not be bloat. Style Elements is freed from that constraint. It can make API changes and as the library evolves over time. And then finally, there's this mantra of sort of, if it compiles, it styles. This is like an aspiration. Something that people report when they're using Elm is this feeling of, if it compiles, it just works. And Style Elements aspires to bring that same feeling to styling things. Like if it compiles, if the compiler says this looks good, the idea is that it should work and it should give you what you expect. So, having said all this, I do want to caution you, like, this is a massive effort, and it's under heavy development. This is not something I would say, run out and start using this right now, because, I mean, it's a huge effort to try and design a new layout system from scratch. Having said that, there are some enthusiastic early adopters, some brave souls, including Oliver here, who reported this in the Elm Slack, and you probably can't see these numbers, but I'll bottom line it for you. He had 25,000 lines of code, and he went down to 15,000 lines of code when he replaced his Sass with Style Elements. Now, granted, lines of code is not a metric that tells you a whole lot of information, but that is the type of thing that at least makes me sit up in my chair and go, okay, that's a lot. that's a pretty substantial change. And as he didn't quite say in this quote, he ended up feeling that it was a lot more maintainable over the long term. If you like this idea of clean slate semantics, I highly recommend checking out Elm. So we've been using it at work at No Red Ink. We've still had no runtime exceptions from our Elm code because the compiler is amazing. In 2 years, 200,000 lines of code still has not happened. Our legacy JavaScript still throws plenty of runtime exceptions, but that's okay. It's mostly Elm now, so that part of the code base has been excellent. It's got its own separate package ecosystem that's totally separate, so we don't actually use NPM for any of our package needs. And semantic versioning is automatically enforced, like across every package in the library. If I try to publish a package that makes a breaking change and I don't bump the major version number, Elm package literally will not let me publish it. It'll say, nope, that was a breaking change. You need to bump the major version number. All of these things are possible because Elm has this idea of clean slate semantics and just saying, we're going to say JavaScript is bytecode, we're going to compile to JavaScript, and we're not going to keep any of the semantics with it. If you'd like to learn more about Elm in general, there's a guide, elmlang.org. There's an awesome Slack channel with people who are super helpful and beginner-friendly. I'm writing a book, shameless plug, Elm in Action for Manning Publications. It's available for early access, and I'm doing a free workshop tomorrow. So if you'd like to come, I believe there are still some seats left, which may not be true now that I've said that. To sum up, so CSS was never intended to create user interfaces. We know this, but we can build a new foundation by treating CSS as bytecode. Thanks very much.